Now, question number 4. Question number 4 is dy by dx plus root 1 minus y square by root 1 minus x square. So I have written in this way. It is all the term is in a single square root. So I made it in separate square roots. Okay, that we can do equal to 0, and I take dy by dx equal to minus root 1 minus y square by uh, root 1 minus x square. So you can see that this is in the variable separable form. Variables can be separated. So what we do is dy is kept as it is, and this root 1 minus y square we brought here equal to minus dx divided by square root of 1 minus x square. So variables are separated to both the sides. Now how do we solve this? Integrate on both sides. The variable separable form, root 1 minus y square equal to minus dx by root 1 minus x square. What is the integral of this one? That is, it is in the standard form, sine inverse y equal to minus sine inverse x plus c. So the general solution is sine inverse x plus sine inverse y equal to c. This is the solution. Now our next question is show that the general solution of the differential equation dy by dx plus y square plus y plus 1 by x square plus x plus 1 is equal to 0. By observing, you can find that this is also in the variable separable form. So we separate in the variable separable form. So dy by dx equal to minus of y square plus y plus 1 divided by x square plus x plus 1. So we write in this way. Now dy by y square plus y plus 1 equal to minus of dx divided by x square plus x plus 1. Now both sides we have to integrate to get the solution. This is in the variable separable form, so we integrate both sides. Okay, so integrate both the sides, so we get the solution. That means we have to integrate these two. Okay, let us try to integrate 1. So how do we integrate dx by x square plus x plus 1? See, you have to complete it as a square. Dx by x square. For completion of square, what we adopt is the middle term we take. The coefficient of middle term is 1, and its half is 1 by 2, and its square is 1 by 4. So we need to add the square 1 by 4. So that is what we do here. X square plus x plus 1 by 4. So if it is 1 by 4, actually here we got 1, and instead of 1 we are writing here 1 by 4. So the remaining 3 by 4 should be added there. Okay, so this is how we complete the square. Dx by, and this term, these three terms together will be x plus 1 by 2 whole square. 1 by 2 whole square. And this can be written as root 3 by 2 the whole square. So it is in the standard form. Dx divided by x square plus a square. Dx divided by x square plus a square. This form we get, which is equal to the formula, that is equal to tan inverse. So answer is 1 by a tan inverse x by a. So we are using this formula here. 1 by a means 1 by root 3 by 2 tan inverse x means x plus half x by 2 by a. A is again root 3 by 2. So we got this as the solution of the right hand side. So the left hand side is also the same terms, but the variable is on the difference is in variable only. So here we can write it as 2 by root 3 tan inverse uh, tan inverse. This I can change it as 2x plus 1 by 2 by root 3 by 2. This 2 and 2 getting cancelled. So I can write it as 2x plus 1 by root 3. So this is what is the solution. Now so we have as constant also. Let us take it as C1. So here the formula will be of the same form, 2 by root 3 tan inverse 2y plus 1 by root 3 we write equal to, and this is minus, and minus let us bring here, plus 2 by root 3 tan inverse, instead of x y we have x here, 2x plus 1 by root 3. And one thing, here we have a constant, here we have another constant, and both the constant together we write it as c. So this is the solution. This is the solution, tan inverse 2 by 3. So tan inverse 2y by 3, you multiply both the sides by root 3 by 2. So root 3 by 2, if you multiply, this will be getting cancelled, this will be getting cancelled, and it becomes c root 3 by 2. So tan inverse 2y plus 1 by 3 plus, we multiply it by what? Root 3 by 2. Completely we multiply by root 3 by 2. And here also we have to multiply root 3 by 2. So this root 3 by 2, both 2 by root 3 and 2 by root 3 will be getting cancelled by root 3 by 2. So tan inverse 2y plus 1 by root 3 plus this 2 by root 3 also disappeared, 2x plus 1 by root 3 equal to c into root 3 by 2. Okay, c into root 3 by 2. Now let me finish this. Okay, let us forget this part. Yes. Now you can simplify furthermore. Tan inverse A plus tan inverse B. So that is tan inverse A plus B form. Tan inverse A plus tan inverse B. Tan inverse X plus tan inverse Y. The formula is tan inverse X plus Y by 1 minus xy. This formula I am applying here. Okay. Tan inverse tan inverse x is 2y plus 1 by root 3 plus y is 2x plus 1 by root 3 whole divided by 1 minus 1 minus 2x plus 1 by root 3 2x 2y 2y plus 1 by root 3. So again if you simplify, and that is equal to c root 3 by 2. So if I simplify this, tan inverse 2y plus 1 plus 2x plus 1 by root 3 will come, divided by root 3 into root 3, 3. 3 minus 2x plus 1, 2y plus 1 divided by 3. So what happens is root 3 here it cancelled, here 1 root 3 will remain. Okay, implies tan inverse of this root 3 goes there. Root 3 2x plus 2y plus 2, 2x plus 2y plus 2 on the top, divided by what happens here, you see 3 minus 4xy, 4xy I expand it, 2x into 2y, 2x minus 2x minus 2y, we expand the bracket, minus 1. Okay, this is equal to c root 3 by 2. So up to this we have done, and let me completely erase this much. So our solution reaches here. Okay, solution reaches here. So this is the final solution, and we can further simplify it. Tan inverse, okay, tan inverse is equal to this much. So this tan inverse, let us bring there. So root 3 2x plus 2y plus 2 divided by 3 minus 1. Okay, 3 minus 1 is 2. 2 minus 4x minus 2x minus 2y, see, is equal to, this tan inverse goes there, then it becomes tan c root 3 by 2, tan c root 3 by 2 it becomes. So that is again a constant, a new constant, we call it as capital C. So far we took it as small c, so now it becomes, that means tangent of c root 3 by 2, we replaced it as capital C, so we got a constant here. Okay, what is our question? Our question, once again, you see, x plus y plus 1 is equal to a into, let us see whether we can make it in that form, 4xy here. Okay, so what we do is, we take root 3 into 2, I take outside 2 root 3. Okay, x plus y plus 1 is equal to c, which is a constant, into, again from this bracket also I can take 2 outside, and this bracket and their bracket we bring here, 2 is outside, 1 minus 2xy minus x minus y, that is exact term, 1 minus x minus y minus 2xy. Okay, and this x plus y plus 1 equal to 2c divided by 2 root 3 into 1 minus 2xy minus x minus y. Okay, minus y. So we got it, and c is cancelled. Whatever it may be, c by 3 root 3 is again a constant. So we substitute that term by a new term equal to a, 1 minus 2xy minus x minus y. So exactly what we got, where a is a parameter, a is a constant. Question number 6. Find the equation of the curve passing through the point 0 pi by 4, whose differential equation is sin x cos y dx. Sin x cos y dx plus cos x sin y dx equal to, let me write, minus cos x sin y dy. Alright. So we have to find out the equation of the curve passing through the point 0 pi by 4. For that, first of all, we have to, this is the differential equation and we have to solve that. Eh? We get the solution of that differential equation. So how do we solve this? So for solving this, we have to check which type it is coming under. So sin x cos y dx equal to minus cos x sin y dy. And can we separate the variables sin x dx by cos x? So all the x terms I have collected, and minus sin y dy sin y dy divided by cos y. So this is tan x dx equal to, this one is minus tan y dy. Okay, now this is variable separable, variables are separated. Now the solution, the integration of both sides, integral tan x dx equal to minus integral tan y dy. What is integral of tan x? Integral of tan x is log sec x. Log sec x equal to minus log sec y, and plus constant of integration, that also we write in terms of logarithm of c. Okay, logarithm of sec x plus logarithm of sec y equal to log c. Logarithm of sec x sec y equal to log c. Okay, sec x plus, sorry, sec x sec x sec y is equal to c. This is the solution. Now one more thing is given, the curve, this is the family of curves we got, and we had to find out a particular curve which is passing through. What is the speciality of that curve? It is passing through 0 pi by 4. That means x is equal to 0 and y is equal to pi by 4. So we put x is equal to 0, sec 0, and y is equal to sec pi by 4 equal to c. And sec 0 is equal to 1 by cos 0, and sec pi by 4 is equal to 1 by cos pi by 4, that is root 2 equal to c. We got c is equal to root 2. So putting it in the general solution, sec x plus sec y equal to root 2 is our solution. Sorry, multiplication, sec x into sec y, and it can be written as 1 by cos x into 1 by cos y is equal to root 2. We want, so this is the solution. In any way you can find out. Question number 7. Find the particular solution of the differential equation 1 plus e raised to 2x dy plus 1 plus y square e raised to x dx equal to 0. So first of all we will check which category it falls into. So we write for that, we write 1 plus e raised to 2x dy equal to minus 1 plus y square 1 plus y square 1 plus y square e raised to x e raised to x dx. Now with the dy we try to collect all the y terms, 1 plus y square and with minus e raised to x dx by 1 plus e raised to 2x. So here we find that the variables are separated. Now we integrate. Solution of variable separable is after separating the variables we have to integrate. So dy, this is the solution, 1 plus y square equal to minus integral e raised to x dx divided by 1 plus e raised to 2x. So this is in the standard form, the solution of which is tan inverse y, and let us check how to integrate it. We go for a substitution. E raised to x is equal to t, so that e raised to x dx becomes dt, right? So it becomes e raised to x dx is equal to dt by 1 plus e raised to x whole square. It is e raised to x means e raised to x whole square. E raised to x whole square means t square. So now this is also converted into the standard form, which is tan inverse t. Tan inverse t means tan inverse e raised to x. So the the, the equation is, sorry, the solution is tan inverse y equal to tan inverse e raised to x, uh, here minus is there, plus c, tan inverse y plus tan inverse e raised to x equal to c. Okay, now this is the solution, and we put x is equal to 0. What is given? X is equal to 0 and y is equal to 1 here. X is equal to 0 and y is equal to 1. Tan inverse 1 plus tan inverse e raised to 0 is equal to c. Tan inverse 1 is equal to pi by 4 plus pi by 4. Tan inverse e raised to 0 is also tan inverse 1 equal to c pi by 4, 45 plus 45, 90. That means c is equal to pi by 2 radians. So we substitute it here in this solution, so that we get a tan inverse y plus tan inverse e raised to x equal to pi by 2, which is the solution. Now question number 8. Solve the differential equation y e raised to x by y e raised to x by y dx equal to x e raised to x by y plus y square dy. Now since e to the power x by y has come, from this we can understand that this is coming under homogeneous differential equation of the form dx by dy. Okay, so we write it in that form. We convert dx by dy equal to x e raised to x by y plus y square divided by y e raised to x by y. Now we go for substitution. X is equal to vy. X is equal to vy. Dx by dy is equal to v, derivative of y is equal to 1 plus y dv by dy. Okay, now we substitute it here. Dx by dy, instead of that, v plus y dv by dy equal to x, we substitute vy. E raised to x by y is x, x by y is equal to v. E raised to v plus y square by y e raised to v. Now I take y on both sides, y v e raised to v plus y divided by y e raised to v. This y and this y getting cancelled, so we got v plus y dv by dy equal to v e raised to v plus y by e raised to v minus, what we do is this v we will bring here. Okay, so this minus v, so it becomes v e raised to v plus y minus v e raised to v all divided by e raised to v. Here one thing you can observe, this term and this term getting cancelled. So finally what we get here is y dv by dy is equal to y by e raised to v. So this y and this y getting cancelled, and e raised to v is kept here. E raised to v dv is equal to dy. Now this is in the variable separable form. We integrate integral e raised to v dv equal to integral dy. E raised to v dv is e raised to v, dy is y plus c. E raised to v is x by y. E raised to x by y is equal to y plus c. E raised to x by y is equal to y plus c is the solution. Question number 9. Find the particular solution of the differential equation x minus y dx plus dy equal to dx minus dy. And the values are given, y is equal to minus 1 and x is equal to 0. Particular solution we have to find out. Now we have been given a hint here. We have to put x minus y is equal to t. So let us see how it can be rewritten or modified, or can it be written in our standard type. X minus y dx plus x minus y dy equal to dx minus dy. So what I write is x minus y dy, and here minus dy is there. Minus dy, when it comes here, it becomes 1 dy, and dx is there, x minus y is there. So dx is common factor there. So I bring this x minus y here, 1 is here, and x minus y. Okay. Now dy by dx is equal to 1 minus x minus y, 1 minus x minus y, like this, x minus y by x minus y plus 1. Now it is given that we have been given a hint that x minus y should be substituted as t. So x minus y, when we substitute as t, so dy by dx, what will be dy by dx? So you differentiate with respect to dx minus y is equal to t. If you substitute, you differentiate it with respect to x, 1 minus dy by dx equal to dt by dx you will get. Okay. Now what is dy by dx? 1 minus dt by dx is dy by dx. We interchanged the position. We brought this dt by dx to the left hand side and dy by dx on the right hand side. So 1 minus dt by dx is equal to dy by dx. Now we go for substitution. So here we substitute dy by dx can be written as 1 minus dt by dx, and here also you can substitute 1 minus x minus y is equal to t by x minus y is equal to t plus 1. Okay, now dt by dx is equal to, we bring this to the right hand side, 1 minus t by t plus 1. Let us simplify. T plus 1 minus is applicable to both, minus 1 plus t by t plus 1. So we have dt by dx is equal to, so this is our final equation. Dt by dx equal to, this minus 1 and minus plus 1 cancelled, 2t by 1 plus t. So let me clear this. Okay, so now we have this equation, dt by dx. Okay, dt I write 1 plus t, so I take this 1 plus t here, by t is equal to 2 dx. I just modified, our variables are separated. 1 plus t goes there, t will be coming down, so 1 plus t by t dt is equal to 2 dx. So 1 by t plus 1, that means I divide it, 1 by t by t by t dt equal to 2 dx. Now integrate, this is variable separable form, integrate it. So if you integrate, integral 1 by t plus integral 1 dt equal to 2 into integral dx. So the answer becomes log t plus t equal to 2x plus c, and we had substituted t as x minus y. So we will substitute x minus y. So we substitute that, resubstitute. See, the logarithm of x minus y plus x minus y equal to 2x plus c. 2x plus c, logarithm of x minus y. So this x, logarithm of x minus y, this x and this 2x cancelled, that will be x remains there, plus y plus c is the general solution. Now we substitute x is equal to 0, so logarithm of 0 minus y is equal to logarithm of minus 1 minus 1 plus 1 equal to x is equal to 0 plus y is equal to minus 1 plus c. Logarithm of 1 is equal to 0, we know, minus 1 plus c, and c is equal to minus 1 goes to this side, so it becomes 1, c is equal to 1. So our particular solution is y plus x plus y plus 1. This is the solution. So here log x minus equal to log x minus y equal to x plus y plus 1 is the solution. Question number 10. So here the question is e raised to minus 2x by root x minus y by root x dx by dy equal to 1. So if I multiply both sides, see dy by dx is there, otherwise I can say like this, e raised to minus 2 root x by root x minus y by root x equal to dy by dx. dy by dx. So we have converted it in this form. Otherwise, dy by dx plus y by root x is equal to e raised to minus 2 root x by root x. Actually what we did is we have taken this minus y by root x to the right hand side. So dy by dx plus y by root x equal to, it remains unchanged, e raised to minus 2 root x by root x. So you can understand that, or you know that this is in the form dy by dx plus py is equal to q form. dy by dx plus py is equal to q form. It is in linear differential equation form. So here we have to find out, and you know, here if you compare dy by dx and p is equal to 1 by root x py, and q is equal to e raised to minus 2 root x by root x. Okay, now next, so here the procedure is that we have to find out integrating factor. Integrating factor is equal to e raised to integral p dx. Alright, e raised to integral p dx is here e raised to integral 1 by root x dx, right? That means, which is equal to e raised to e raised to 1 by integral 1 by root x. Now what is e raised to 1 by root x? What is the integral of 1 by root x? Integral of 1 by root x is integral of e raised to minus, sorry, 1 by root x. 1 by root x, integral of 1 by root x is 1 by root x means x raised to minus 1 by 2 dx. That is equal to integral, sorry, x raised to minus 1 by 2 plus 1 by 2, 1 by 2 by 1 by 2. That means 2 root x. So the answer of this question is e raised to 2 root x. So this is the integrating factor. Now we know solution of differential equation is y into integrating factor is equal to integral q into integrating factor dx. Now we are going to solve that. Right hand side integration, if we are able to solve, then our question is over. The solution is over. Y into e raised to 2 root x equal to, what is q here? E raised to integral of e raised to minus 2 root x by root x, that is q, into integrating factor into e raised to 2 root x. So what? Y e raised to 2 root x on the left hand side. Here the integral of e raised to minus 2x and e raised to plus 2x, that is 1. Integral of 1 by root x dx. So here dx is there. Now how do we integrate it? That is again e raised to integral of, sorry, not e raised to, integral of x raised to minus 1 by 2 dx, and we have seen that that is equal to 2 root x. Okay, so answer is y into e raised to 2x raised to root 2x equal to 2 root x plus c. So this is the solution. Question number 11. Question number 11 is, find particular solution of the differential equation dy by dx dy by dx plus y cot x equal to 4x cosec x, and here this is also in the linear differential form. Here cot x is p and this is q. Now here again we find the integrating factor e raised to integral p dx. So e raised to integrating factor is equal to e raised to integral cot x dx. Okay, so that is e raised to cot x dx is integral of cot x dx is log sin x. So integral log sin x. So e raised to log sin x, you know, e raised to log x is x again. So e raised to log sin x is sin x. So sin x is the integrating factor here. Now the solution of the differential equation, solution of this linear differential equation is y into integrating factor is equal to integral of q into integrating factor dx, and y into integrating factor y sin x equal to integral 4x cosec x into integrating factor. Integrating factor is sin x dx. Now we have a convenience here. Cosec x and sin x, they will cancel. Cosec x is 1 by sin x. 1 by sin x into sin x, those terms will be getting cancelled. So y sin x equal to integral of 4x dx. The answer is y sin x equal to 4x integral is x square by 2 plus c. Y sin x equal to 2x square plus c is the general solution of the differential equation. Now we have to substitute the values. Y is equal to 0 when x is equal to pi by 2. Y is equal to 0 is substituted. So sin pi by 2, so 2 pi square by 4, because x is to be substituted by pi by 2. Pi by 2 square is pi square by 4 plus c. So this becomes 0. C is equal to minus pi square by 2. Okay, so the solution, final solution is, what is it? Y sin x equal to 2x square plus c. Instead of c, we can substitute here pi square by 2. This is the answer. Question number 12. X plus 1 dy by dx equal to 2 e raised to minus y minus 1. So x plus 1 dy by dx equal to 2 pi e raised to y minus 1. That is equal to 2 minus e raised to y by 2. So let us check the equation. You can see that x terms and y terms can be kept separately. So e raised to 2 minus e raised to y by, here it is e raised to y. So e raised to y by 2 minus e raised to y dy is equal to dx divided by x plus 1. So it is in the variable separable form. So you integrate integral e raised to y by 2 minus e raised to y dy is equal to integral dx by x plus 1. So here we can substitute e raised to y. E raised to y is equal to t. So e raised to y dy is equal to dt. So here we substitute dt by 2 minus t. So answer is 2 minus t, the logarithm of 2 minus t by minus 1 minus t, because of this minus 1 we substitute divided by minus 1. So answer of this left hand side is logarithm of 2 minus e raised to y. That is what is t. E raised to y by minus 1 is there, minus equal to minus log, not minus, log x plus 1, log x plus 1 equal to c. So this logarithm sorry, plus c or plus c, anywhere you can write, log x plus 1 plus log 2 minus e raised to y equal to c, like that you write. So here no need to confuse, here you write c, here anywhere you can write c. So logarithm of x plus 1 into 2 minus e raised to y equal to c, or else x plus 1 into 2 minus e raised to y equal to exponential of c. Okay, exponential of c is again a constant, so you can write it in the form x plus 1 into 2 minus e raised to y equal to, instead of this e raised to c, capital C, right? So this is the solution. All right, so now we put the value y is equal to 0 and x is equal to 0 here. X is equal to 0, 1, y is equal to 0, 2 minus e raised to 0, 2 minus e raised to 0 is 1, so that is 1. So which means we get c is equal to 1. So our formula reduces to x plus 1 into 2 minus e raised to y equal to 1. This is the final solution. Now we have question number 13. Question number 13, we will write the y dx minus x dy by y is equal to 0. It means that y dx minus x dy equal to 0, y dx is equal to x dy, and dx by x equal to dy by y. Integrating, it is variable separable form, integrating integral dx by x equal to integral dy by y to log x equal to log y plus log c. We write in this way. So x is equal to log x is equal to, which is equal to log cy, which means x is equal to cy. X is equal to cy. Okay. Now x is equal to cy is the solution, or y is equal to cx. So the option C is correct. Actually it is x is equal to cy or y is equal to 1 by c x. Y is equal to a constant into x. That is how we got this solution. Question number 14, that is also again MCQ. So let us check it. The general solution of differential equation of the type dx plus dy plus p1x plus is equal to q1. So this is coming under variable separable form, but it is in the form dx by dy. The solution of dx by dy form is x into integrating factor is equal to integral q1. Here it is given q1 dy. Okay, q1 dy. So this is the solution. X into integrating factor. What is integrating factor? Integrating factor is e raised to integral p1 dy equal to integral q1. Integrating factor is e raised to integral p1 dy plus c. So our option this one is correct. C is correct. Now question number 15 is general solution of the differential equation e raised to x dy. So this one, let me erase. E raised to x dy plus y e raised to x plus 2x dx equal to 0. So actually, what kind of equation is it? First we will find it out. E raised to x dy equal to minus y e raised to x plus 2x 2x into dx is there. Let me write that dx here. Dx. So dy by dx equal to minus of y e raised to x plus 2x. So this e raised to x will go there. E raised to x by e raised to x. So all this will go. So now what happens is dy by dx equal to e raised to x and e raised to x cancelled, minus y. Okay, equal to this minus will come here. So here it is minus minus y minus 2x by e raised to x. So dy by dx plus y equal to 2x by e raised to x. Understood? So what is the integrating factor? This is also in the form dy by dx plus py equal to q form. Integrating factor is integral e raised to p is here 1 dx. 1 dx, that means e raised to x only. E raised to x. Solution of this differential equation is y into integrating factor equal to integral 2x by e raised to x into integrating factor dx. So e raised to x and e raised to x getting cancelled. So y into e raised to x, only we have to find out integral of 2x square by 2, it is x square plus c. So we'll check whether this term is somewhere here. Y e raised to x is there, y e raised to x. So option C is correct. Here minus is there, that is it. Minus is there, minus. So y e raised to x plus x square equal to c. Y e raised to x plus x square is equal to c. Option C is correct. Okay, thank you.